Good morning, everyone. Welcome back to the Wake Up Show on a Saturday. This is the Halloween edition of the Extreme Science Center. We are joined by Radical Rick, and making her Extreme Science debut is your granddaughter, Aubrey. Thanks so much for being here, guys.
Thank you.
So what are we talking about today?
Today, we're going to talk about dry ice.
All right, so I got to put my goggles on.
Yes, with Halloween coming, I know that a lot of you guys get dry ice out there because I've been talking to your kids, okay? So I know that you guys get a lot of dry ice out there, and I wanted to talk a little bit about the safety of dry ice. Now, dry ice is a little bit different from regular ice, and you can see, what do you see coming off of there, Aubrey?
Smoke.
Yeah, it looks like smoke coming off of there, but it's actually going downward. That is carbon dioxide gas coming off there because dry ice is made from carbon dioxide gas. Regular ice is made from water. So if we took a regular piece of ice and I put it on the table there, if I came back 2 hours later, what would I find?
Water?
Yes, because it would melt.
She's good.
So,
she's doing a good job for her first show.
So yes, regular ice goes from a solid to a liquid because we heat it up. We're changing the temperature. We can change it from one state of matter to another by changing the temperature. Now, that puddle of water, if I waited like 2 weeks, would that puddle of water still be there? No, because it would evaporate and change to a gas. Now, dry ice is different because it goes directly from a solid to a gas. Since this is made from carbon dioxide gas, this is a frozen gas, and it is minus 115 degrees. Okay, now that process going directly from a solid to a gas is called sublimation. Can you say sublimation?
Sublimation?
That's a hard word, yes, sublimation, very good. So we can do some fun stuff with dry ice, and I wanted to show you some fun things that you can do with dry ice, but again, be safe. Number one is always wear gloves, wear glasses, safety glasses, because you don't want to get any of this in your eyes.
Right.
Think about that, minus 115 degrees in your eyes. That would hurt.
Good.
Yeah, and when you're breaking this up, always wear the glasses because, you know, for most of the experiments, we will break it up into smaller pieces. So I do use a hammer, I put it in a bag and then hammer it, but you want to make sure that that's not splashing up and, you know, little pieces breaking off into your eyes. A lot of times the little pieces will drop down into my gloves and you can feel it right away because it's so cold, it'll actually give you a cryogenic burn. And so then I'll get it out of my glove. But like I say, be safe with it.
Safety is the biggest thing dealing
and kids,
with this.
you're not allowed to touch this, only your parents,
Right.
okay? And now if you take a quarter and we put this quarter in the dry ice, if I force it down into the dry ice, you can hear it kind of squeaking and squealing, but check out what happens there.
Whoa.
Isn't that cool? That quarter is actually bouncing around, and most people think it's because that quarter is so cold. Because if I was sitting on there, I think
Shivering,
I'd be
right?
bouncing around too. But that quarter is actually bouncing because of the sublimation process, and you can see I'm kind of holding this at an angle so that that quarter will lean down and up, you know, lean up against the dry ice. So as it's leaning up against the dry ice, that quarter feels really hot to the dry ice, and it's speeding up the sublimation process. So all that gas is coming off of there. It's changing from a solid to a gas. A gas takes up more space, so it's actually pushing on the quarter. Now you can see the quarter has slowed down, and it's barely vibrating. If you listen really close, you can hear it vibrating. I doubt they can. I doubt they can hear it at home, but it's barely vibrating, and that's because it's getting so cold. So now the process, the sublimation process, is slowing down.
White.
Yes, it turned all white. Now, would you want to touch that quarter?
No.
No. Again, safety is number one. So we're going to take some other dry ice here, and I'm going to go ahead and get my other glove on, and we're going to speed up the sublimation process by putting some dry ice in hot water. So I've got some hot water here in this Erlenmeyer flask, and we're going to drop this down in there, and now you can see all of the gas that's coming off of there. Isn't that cool looking? Now this one, I think we did a while back with Carson and Kira when they were here. We can take
She's like, hey, watch out for that.
Okay, good thinking. Yeah, now remember the dry ice you can't touch, but the gas, it won't hurt you. Yeah, you can touch that, and you can actually taste it. Now I don't want you to breathe in, just go like that, and you can taste it, and that kind of tastes like club soda. Because our pop is all carbonated by carbon dioxide gas. And so now this one we're going to take and we're going to actually put a little bit of bubble solution in this one here. When you put the bubble solution in there, now all of those bubbles, like this one here, you can see the dry ice sitting down at the bottom and it's all sublimating and changing to a gas. All those bubbles are coming up, popping, releasing the gas, and all the gas is coming out. Since we've got some bubble solution in there, that one, those bubbles won't pop. It'll actually have bubbles coming out of the top. And this one, since we're going to be handling those bubbles,
Got
I
a
want to
lot of
make
dry
sure.
ice over there, Radical Rick.
Yes, I want to
We're
make
messing
sure
around.
and only grab some big chunks, because if we get any of that powder down in there, all that powder would actually work its way up in through the bubbles. So if you ever do this, make sure that you're only using the larger chunks that will sink down to the bottom. Now, look at this. Look at all those bubbles. Isn't that cool? Now you can take, and I'll give you some of these. You can grab some like that, and you know, you can put them, yeah, there you go. Isn't that cool?
Thank you.
I was thinking,
really
you know,
cool.
that would be really cool to put inside of a pumpkin, a little dish in there with your hot water and some dry ice and some bubble solution, and then that way you got bubbles,
yeah.
you know, all these bubbles coming out of the pumpkin's mouth and stuff. So, you know, you could get creative with that and have some fun. Now, this one here is, we're going to talk about the fact that the carbon dioxide gas is heavier than air. And so if we put some dry ice into this bucket here, and this one, doesn't matter if we get the powder or not. Actually, if we put the powder in, there's actually more surface area with the powder, and so you'll actually get a lot more smoke. So when you, or carbon dioxide gas coming off there.
Okay.
So when you break it up, it'll actually produce a lot of gas a lot quicker. And stay right there, and don't worry, this won't hurt you. I'm just going to pour it right over your head, just like that. Because the carbon dioxide gas is heavier than air, so if you're putting it in a bucket like this or in your punch
That's
bowl,
pretty spooky looking, huh?
it'll come up like that, and then you can see all the gases going down across the table, because carbon dioxide gas is 1.5 times heavier than air. Okay, a lot of times kids will tell me in class and stuff that they, at Halloween time, their parents put the dry ice in their punch, and it's really cool and stuff. Just be careful, because you don't want anybody to actually grab a glass that has some dry ice in there and end up drinking it. Remember, safety first. Now, this one here is one of my favorite dry ice ones. Oops, took off the wrong glove here. So this one is a camel pack that I've modified, and because normally the hose comes down, you fill this up with water, and you can drink the water out of the hose. This one, like I say, I've modified a little bit. So the hose actually comes out of the top. I've sealed up the hole at the bottom.
This is one of these hiking backpacks, right?
Yep. Now I've got some warm water down there. I've got the dry ice up here. I'm going to flip it down like that. Now all of the gas is coming out of the hose. So now I can put this backpack on, and we can actually take Mr. Bubbles' bubble solution and stay right there, and go ahead and look at the camera there, Aubrey, and check this out. You can blow these really cool bubbles full of carbon dioxide gas.
It's a good look
Isn't
for
that
you.
cool?
Aubrey, that's a great look for you. You should think about that.
So like I say, that's one of my favorite dry ice experiments there. These, yeah, we do the dry ice experiments at the birthday parties, at the after school programs and stuff. This is another one that you can do at home. We've just got 3 bowls here with a little bit of warm water in there, and what I did is took a little bit of bubble solution here, or Dawn dish soap, and you just want to get the top of the bowls wet here. Excuse me, Aubrey, I don't want to push you off there. There we go. And now we're going to drop some dry ice down in there. Let me grab some dry ice for you ladies.
No shortage of dry ice here today.
Yes, and Ali, if you want to go ahead and pull those strings out and just kind of get most of the liquid off of there. We've just got some cotton strings there.
Want to help me with that?
And we're going to use those to create some really cool looking bubbles across the bowls there. So here's some dry ice for each of you. And we'll reach right across there, Aubrey, and put some dry ice in here. Ooh. Put some dry ice in there and there. And now you can go ahead and, whoop, there you go. Drag your string across the top there. You should be able to seal a bubble off of the top if you get enough. And here.
I don't know, Radical Rick.
Oh, it'll work. It'll work. Like I say, it takes a little bit of practice, but yeah, you gotta make sure and get it all the way to the end there.
I think I was close on that one.
There we go. Oh, I just popped it as I pulled it off.
3 hours later.
No, it will work. It's really cool. There we go. So now, oh, it just popped.
I
There
think
you
I
go.
got it.
Allie's got it. Yeah, you got to get the right amount on there, and that's what science is all about, is learning. And so if it doesn't work the first time, don't get frustrated with it. Just keep trying it, because it
all
will,
about experimenting.
you know, you'll learn what does and doesn't work here.
Well, Radical Rick, thank you so much for being here yet again to show us some of these experiments that could certainly make your house look a little bit spooky for Halloween, and also for reminding us that safety is, of course, almost always the most important thing.
Yes, safety first.
Thanks for being here. And
Thank
Aubrey,
you.
thanks so much for being here too.
And I'm
We hope
so
you
sorry.
see you back.
So sorry that this, oh, there we go. Now we got one to work.
Oh, yeah.
There we go, because I want them to see this. It's so cool, because this will actually now grow.
got
There
it
you go,
too.
there you go.
Oh, great.
So
Well,
it just
thanks
takes a
so
little bit
much,
of practice.
guys.
And if you got bubble solution on your finger, you can actually stick your finger
Whoa.
through the bubble. Isn't that cool?
Well,
So
thank
have fun
you,
with
guys.
it and be safe.
Yes, absolutely. Thanks so much, Matt. I will send it back over to you.